Hello again, everyone, and welcome back to science class. So, we are going to continue learning about solar energy, building upon what we learned last time about PV cells or solar cells. So, let's get started. Like I said, we're going to focus on that last objective, specifically how PV or photovoltaic cells work. Now, we talked about last time that PV cells are made of silicon because it's a good conductor of electricity. We also know that boron and phosphorus are added to create more holes in the silicon for the extra electrons. But silicon on itself, pure silicon, would reflect 30% of sunlight, which means that we would only absorb or capture 70% of the radiant energy. That's not good, all right? We want to capture as much as possible. So we add a glass layer. Glass only reflects about 5% of the radiant energy. So, we're able to absorb or capture 95% of the radiant energy of the sun, which is good. Now, beyond that, solar cells require 2 layers of silicon, okay? This is where our other elements, phosphorus and boron, come into play. The top layer of silicon has phosphorus added. Now, phosphorus has 5 electrons. We know from before that silicon has 4 electrons. So with phosphorus's 5 electrons, it adds an extra free electron to that layer of the silicon. So let's look at that. All right, we're adding in the phosphorus and we've got that extra electron there. Now this layer of the solar cell now has a negative charge. Okay, now that, just getting back to that phosphorus element for a moment, that extra electron is going to be critical. That's the thing that's going to move within the solar cell. In fact, the only thing that will move within the solar cell, and that's what's going to create electricity. So, the bottom layer of the PV cell has boron added to it. Boron, on the other hand, only has 3 electrons, and it leaves a hole in that layer of silicon. So we've got a hole being created. Now this is going to be important because as that extra electron from the phosphorus begins to move, it's going to need a place to come back to. And that hole within the boron is where it's going to go. Now, this layer of the solar cell has a positive charge. Now, because the PV cell has 2 layers, they have to meet somewhere. Now, where these 2 layers meet is called the p-n junction. Because of the negative charge on the top layer, or of the top layer, and the positive charge of the bottom layer, the p-n junction creates an electronic field, and this pushes those free electrons. So it's going to start moving those extra electrons between the layers. This is going to help us, again, create electricity, all right, through movement of electrons. You see the little picture there, all right? You've got the top P layer, the p-n junction, and then the N layer, all right, the bottom layer. Now I've created this kind of rudimentary PV cell here for us to label. So on your worksheet, I want you to fill these in. So at the heart of our PV cell, we've got the N layer silicon, and this is the layer that has phosphorus added. On the bottom, we've got the P layer silicon. This is where the boron is added. Okay? Remember, phosphorus has an extra electron. Boron is missing an electron. It has an extra hole. And because of the different charges, we have a p-n junction, which creates an electric field. Now, above and below these layers are metallic conductors, okay? Metal conductors. Right? This is how the electricity is going to travel out of the silicon, out of the PV cell, create electricity, and then come back into the PV cell. All right? Of course, we've got a protective layer. We don't want our solar cell to get broken or damaged or hurt in some way. On the bottom, we have the frame. Right? Got to have it setting somehow. And on the top, the glass layer to ensure sunlight is not being reflected too much. So this is essentially a simplified version of our PV cell. Okay? We've got our different layers of silicon, our metallic conductors, our protection, our frame, and our glass. So how does a PV cell work? So my goal here is I'm going to go over the steps, and then I hope that when we get back to school, we can go over this again more thoroughly, looking at specific examples. So, number one, photons from the sun hit the solar cell. And when they hit the solar cell, they give the electrons energy. When they do this, they also knock them from their atoms, creating a hole. Okay? Now, a photon is just something that carries light through space. All right? It's carrying that radiant energy of the sun. And again, these photons are knocking electrons free from their atoms and giving them energy. Now, the electronic field created by the p-n junction pushes that free electron, that extra electron, to the top of the silicon. And this is because it has a negative charge. At the same time, right, we've got that hole that was created when the photon knocked that electron free from the atom. That hole is going to be pushed to the bottom because it has a positive charge. Now, as this extra energized electron moves upward, it's eventually going to move through the conductive layer, those metallic conductors. Okay? The energized electron is going to be removed, or is going to move from the silicon, all right, out of the PV cell. The energy is going to be removed from the electron and used as electricity. And then that electron, now kind of devoid of energy, is going to return to the bottom of the silicon to fill the hole that was created when that photon knocked it free or in the first step. So this sounds like a lot, okay? And it is. We've got photons knocking electrons free from their atoms and giving them energy. The electron is going to be pushed to the top of the silicon, while that hole that was created is pushed to the bottom. That energized electron is going to move out of the silicon. The energy is going to be removed from it to be used as electricity, and the electron is going to return to the bottom of the silicon and fill the hole. And this process is going to be repeated again and again and again and again and again, creating electricity. Now, I wanted to do this in class, so we are going to do this when we get to class, okay? It's far too challenging to try to explain on e-learning. All right, but here essentially I've created a PV cell with our elements, silicon, phosphorus, and boron, and we will essentially make a drawing of how a PV cell works in class when we return, okay? So we're just gonna skip through these steps. I'll let you read it if you want though. These steps are essentially just reiterating what we just learned about 2 slides ago. Again, we will do this in class when we get back, okay? I think it makes the whole process a lot more easy to understand. So ladies, I think this is probably the most complicated energy form to understand, simply because it is very, let's say, theoretical, because it's really hard to show exactly how this works. So it's more of explaining than viewing, like we can do with other forms of energy, like let's say hydropower, where we can actually see the dam and how it functions, okay? Anyway, again, please complete the attendance questions and have a good day. If you have any questions, please submit them in the forum. Thank you.